Good morning, students. This is Banu Prasad, working as Assistant Professor in Department of Mechanical Engineering in MBR College of Engineering and Technology. Today we will discuss about define chip and types of chips. So next one is the theory of chip formation one. So these three topics are we are learning today. So go for first one. Theory of chip formation one. So see here the cutting tool removes the metal from the workpiece in the form of chip. So we have the cutting tool. The cutting tool removes the metal from the workpiece one. That one we can call as the chips. So it is the definition of the chip. So as the tool advanced into the workpiece, the metal in front of the tool is compressed, and when the compression limit of the metal has been extended, it is separated from the workpiece and flow plastically in the form of the chip one. So it is the tool advanced one. When the tool is advanced into the workpiece, the metal in front of the tool is compressed, and when the compression limit of the metal has been exceeded, it is the separated from the workpiece and the flow plastically in the form of the chip one. So this one we can call as the chip. So next one is so see here the plastic flow of the metal takes place in the localized region is called as the shear plane. So it is one of the shear plane. So shear plane means so see here it is the shear plane. It is a chip. It is a tool. It is a secondary shear zone. It is a shear angle. It is primary shear zone. It is primary. This one we can call as primary shear zone. So this one we can call as secondary shear zone. So it is the tool one. It is a chip. It is a shear plane. It is a shear angle one. So it is one of the shear one. So in the plastic form, the metal takes place in a localized region is called as the shear plane. So which extended from the cutting edge obliquely up to the uncut surface in front of the tool, or in other words what we call as the shear plane is nothing but the chip is formed by shear deformation one. So see here in this one the chip is formed here shear plane one. So it is the chip completely. This one we can call as this chip one. The chip is formed by the shear plane. So that is the shear deformation. The chip is formed by shear deformation, primary shear. Along a plane is called as the shear plane, which is oriented at an angle pi with the surface of the work. So this one we can call as the shear plane. So see here, it is a shear plane. That is the definition here. The chip is formed here. The chip is formed at the shear deformation one. So the chip is forming here shear deformation only. Along with the plane is called as this one called as the shear plane, which is obtained, which is oriented at an angle of pi one. So the surface of the work is known as the shear angle. This one, it is a shear plane. So it is a block diagram of shear plane. So next one is we can see another shearing. Another shearing action is occurs in the chip after it be formed one. So another shearing also it will be formed. That one is called as in the additional shear is referred to as the secondary shear, to the designated in form of primary shear. So another one, so it is a primary one. So it is a primary shear zone. Next one is secondary shear zone. So here another action occurred. That one is nothing but here secondary shear zone. It is a primary one. It is a primary shear zone. It is a secondary shear zone. So that is the definition here. So this is additional shear is referred to as the additional shear is nothing but here secondary shear to distinguish from a primary shear. The secondary shear result from the friction between the chip and the tool as the chip slides along the rake face of the tool one. So here the secondary shear results from the, how can we get the secondary shear results means so between the chip and the tool, as the chip slides along the rake face of the tool, after that only we can get the secondary shear stress results one. So it is a secondary shear stress. Next one is during the cutting edge of the tool is positioned at a certain distance below the original workpiece. So the cutting edge of the tool is positioned at a certain distance, must and should. Why? Because why? Because to cut the proper cutting purpose, must and should, we can set the tool in a proper position way. So certain distance below the original workpiece one. This corresponds to the thickness of the chip before the chip formation is called as the T naught. This corresponding to the thickness of the chip before the chip formation is called as the T naught. As the chip is formed, so it is the before chip formation is called as the T naught one. So as the chip is formed after chip is formed along the shear planes, its thickness increases T naught equal Tc. So here the T naught equal to Tc. It is before one. Before the chip formation is nothing but T naught. After chip is formed, after chip is will be increased. So that's why it is T naught equal Tc equaled. So this is a major definition. So T naught equal Tc is nothing but before chip formation is equal to. So after chip is formed. So that's why overall chip thickness increases equal T naught equal Tc. Okay. So next one is we can see the diagram T naught C Tc. So here T naught is before one, before chip formation one, T naught. Tc is nothing but after chip formation one. It is a chip, it is a work, it is a tool. This tool, based on the tool, we are removing the chip here, removing the material from the workpiece. The removed material we can call as the chip. It is a workpiece, it is a tool. By using the tool, we are remove the workpiece one. So this workpiece onwards, with the removed material we can call as the chip. That one we can call as Tc. So T naught is called before chip formation amount. Tc is called after chip formation amount. So that's why T naught always greater than the Tc amount. Why? Because Tc is always increasing. So it is a graphical diagram of chip thickness amount. Next one is we can see types of chips. So chips are, we have the different classifications we have. So generally they are classified into different types one. So chip is a small piece of material removed in the course of chopping, cutting or breaking something. So a hard material such as wood, stone or material is called as the chip. Chip is a small piece of material removed in the course of chopping and by using the chopping or cutting or breaking or something. A hard material such as wood and stone of the material is called as the chip. So in the metal cutting operation, chip are separated from the workpiece to impact the required size and shape of the workpiece one. So in this metal cutting operation, chip are separated. Why? Because from the workpiece to impart the required size and shape of the workpiece one. So why we are removing the chip means when we are removing the chip, after then only we can get the required shape and size of the workpiece. So we cannot remove the chip. What happen? The workpiece is workpiece only. We cannot get the desired shape and size one. So that's why machine should, by using the tools, you can remove the chip from the workpiece one. So that is a definition of the chips here. So next one is types of chips. See here. The chips that are formed during the metal cutting operation can be classified into three types. Generally, three chips are classified into three types. The first one is discontinuous, or we can call as segmental chips one. Second one is continuous chips. Third one is continuous chip with the build-up edge one. So these are three types of chips. First one is discontinuous, or we can call as segmental chips one. Second one is continuous chips. Third one is continuous chips with built-up edge one. So these are the different types of chips. The first one is, we will discuss about, the first one is discontinuous chip. So it is a block diagram. Discontinuous chip means properly we cannot get the chip. So improperly we are getting the chip. So that's why we can call as it is one of the discontinuous chip one. It is a tool. It is a workpiece. The tool is removing here. Removed material, this one we can call as the chip. It is a irregular surface due to the chip discontinuous. So see here the brittle work materials, low cutting speed, discontinuous chip. We can see some of the points here. So brittleness work materials. So we can see discontinuous chip is brittle work materials. We can see low cutting speed. Here the cutting speed also very low. Large speed and depth of the cut. Large speed we are using here and depth of the cut. Next one is high tool chip friction. High tool chip friction we are observing here. Low or negative rake angle we can see here. Low or negative rake angle we can see here. So this one we can call as the, discontinuous chip one. So it is the black diagram one. See another point of discontinuous one, discontinuous chip one. So when the brittle material like cast iron or cut, the deformed material get fractured very easily, and thus the chip is produced in the form of the discontinuous chips, discontinuous segments, discontinuous chips, or we can call as segments chip. So see here, when the brittle material like cast iron are cutting, we are cutting here, we are cutting the cast iron material, the deformed material gets the fractured very easily, and thus chip produced in the form of the discontinuous segments. So next one is, in this type, the deformed material instead of the following continuously get erupted periodically. So this one we can call as the discontinuous chip one. So see here, discontinuous chip one, another point also, that discontinuous chip comes off a small chunks or particles. So how can we get the chip formation means? So see here, so small particles we are getting here. So this one we can call as a small chip. This one, that is the definition here. So as they generally provided better surface finishing as the brittle materials only, so discontinuous chip are easily form the chip disposal V.1. So here discontinuous chips are easily to form chip disposal V.1. So these are generally provided better surface finishing purpose, so better material only. However, in case of ductile material, they can causes few surface finishing and unload two life one. So some example, one ductile material we are choosing in the discontinuous chip one, so they causes the pure surface finishing here. So in discontinuous chip formation one, so when we are using the ductile material one, they causes the pure surface finishing and low two life one. So next one is discontinuous chip formation one, cut off the small chunks of particle. When we can get this chip, it may be indicated brittle work material. That was the first point one. Next one is smaller negative rake angle. We can see in this discontinuous chip one. Large speed and depth of the cut and low cutting speed we can see on the discontinuous chips. So these are the one of the classification of the discontinuous chip one. So next one is continuous chips. It is the continuous chips. So continuous good surface finishing. Typically we can get good surface finishing here. So your continuous chips we are using for ductile work materials one. High cutting speed we can see on the continuous chip one. Small feed and depths we can see on the continuous chips one. Next one is sharp cutting edge we can see on the this continuous chip one. Next one is low to chip friction we can see on this continuous chip one. So high or positive rake angles also we can see on this continuous chip one. So these are the continuous chips. Some of the points, few points we can observe here in continuous chip formation one. So next one is, we can see continuous chips are normally produced when the machining steels are ductile material at a high cutting speeds. Continuous chips are normally produced when the machining steels are ductile metals at a high cutting speed. So in continuous chips is normally producing machining steel or ductile material at a high cutting speed. We can see on the continuous chip high cutting speed we can see on continuous chip formation one. So the continuous chips which is like a ribbon flows along a rake face one. So it is one of the main important point about the continuous chips which is like a ribbon flows. It flows very fastly along the rake face one. The continuous chip is possible because of the ductility of the material one. So the continuous chip is possible because of the ductile of the material one. So see here, it is the block diagram of the continuous chip one. This is workpiece one, it is a tool one, it is a chip one. By using this tool we are cutting the workpiece. So see here, continuous chip we can see 1 2 3 4 5 6 7 8 9 10 11 12 up to end of the workpiece one. Though this one we can call as the continuous chips. This is the block diagram for the continuous chips. It is very easy one. So discontinuous chip is we cannot get the sequence one. So that is the major difference between discontinuous chip and continuous chips. So 1, 2, 3 is we can get very fastly. The chip we are getting very fastly here. So and we can see the high cutting speed also we can see in this continuous chip one. So next one is we can see it can be assumed that each layer of the metal flows along the slip plane one till it is stopped by work hardening number. So it can be assumed, you can assume it on continuous chip one. So each layer of the metal flows along the slip plane till it is stopped by the work hardening one. Next one is each of these layers get welded to the previously ones because of the high temperature, thus forming a continuous chips one. Each of these layers get welded to the previous ones because of the high temperature, thus forming the continuous chips one. So see here some of the conditions that promote the continuous chip formation in metal cutting are some of the conditions that can be promote the continuous chips in the metal cutting are: first one is sharp cutting edge, you can see on the continuous chip one. Small chip thickness we can see on this continuous chip one. Large rake angle we can see on this continuous chip one. High cutting speed we can see on this one. Ductile work material we can see on this continuous chip one. So less friction between the chip tool and the interface through one. Interface through efficient lubrication one. So these are the some of the ideal conditions that promote the continuous chips in the metal cutting one. So some of the conditions, ideal conditions that are promoting the continuous chip one. These are the conditions. What are the conditions? These one: sharp cutting edge, small chip thickness, large rake angle, high cutting speed, ductile work material, less friction between the chip tool interface to the efficient lubrication one. So next one is continuous chip. See here, it is the most desirable form of the chip since the surface finishing obtained is good and cutting is smooth. So in cutting chip formation one, the cutting chip one, we can see good surface finishing and we can see cutting is very smoothness we can see on continuous chip one. That is one of the advantages for the continuous chips. In continuous chip, the good surface finishing we can see and good cutting speed and smoothness also we can see on continuous chip one. It also helping having higher tool life and lower power consumption. It also helps in higher tool life. The tool life will be increased one, and lower power consumption will be need one. Lower power consumption will be need, and we can see high tool life is we are using more one. So however, long continuous chips as the turning can cause problems with regarding to the chip disposal one. So long continuous chips we can see we can long continuous chip onwards we can see some causes. Some causes is nothing but some problems we can see. So with regarding to the chip disposal one. So it is the continuous chip armor. So continuous chip also causes a hazards. So continuous chip also it causes some of the hazards. What are the hazards? Means nothing but the machine operators, the work part finishing one. So and then and they interface with the automatic operation of the turning process. So these are the some of the hazards formed for the continuous chip one. So next one we can see chip rule. So a single point cutting tool without a chip breaker showing a long chip rule one. So in continuous chip, see here, it is one of the chip rule amma. So chip rule is nothing but small layer of the workpiece. This one. So it is workpiece. The small layer of the workpiece we can call as a chip rule. A single point cutting tool without a chip breaker showing a long chip rule amma. So next one is see here, groove type chip breaker. This is one type of the chip breaker. So groove type chip breaker designed into the cutting tool itself. So the cutting tool itself it is designed groove type chip breaker. It is one type of the chip breaker also. Next one is we can see another type integrated objection type chip breaker. Integrated objection type chip breaker are in the form of the step made as the integral part of the rake face of the tool one. So integrated objection type chip breaker, it is one of the another type of the continuous chip one. So see here, it is integrated objection type chip breakers are in the form of the step made. It is a step made as the integral part of the rake face of the tool one. So this one we can call as integrated objection type chip breaker one. Next one is clamped on objection type chip breaker. So the clamped on objection type chip breaker designed as an additional device on the rake face of the tool one. So it is also one of the chip one. So it is clamped on the, it is clamped, see here it is clamped on the objection type chip breaker one, designed as the additional device on the rake face of the tool one. So another one additional device is it is fit on the rake of the face tool one. So this one we can call as clamped on objection type chip breaker one. So next one we can see continuous chip breaker with the third one. So the third chip formation one. So it is very important one. The chip breakers are generally we have the three types. The first one is discontinuous chip breakers. Next one is continuous chip breakers. The third one is continuous chip breakers with built-up edge one. So it is the built-up edge one. So see here, it is a tool particle blue in a new surface one. It is a built-up edge. This one we can call as this red color one. We can call as the built-up edge one. So it is the ductile materials, low to medium cutting speed. The cutting speed are very low at the continuous chip with built-up edge one. Tool chip friction causes portion of the chip to adheres to rake face one. Tool chip friction also causes here. Next one is blue forms, then breaks of the uh, uh, clinally. So blue forms breaks of the, it is the blue form, it can be breaking is nothing but here. So it is removing one. So it is called as the continuous chip break with a built up edge one. So next we can see when machining the ductile metals at low to medium cutting speed, friction between the tool and the chips tends to cause a portion of the work material to adhere to rake face of the tool near cutting edge one. So when it is the working of the continuous chip break up with built up edge one. So when machining ductile material at low to medium, so the machining ductile materials. So we are machining the in continuous chip formation one. The material is ductile material, low to medium cutting speed. The cutting speed of the chip is nothing but low to medium one. Friction between the tool and the chip tends to, the friction between the tool and the chip tends to cause the portion of the work material to enhance to rake face of the tool to near the cutting edge one. So this is the one of the working one. So this formation is called as the built up edge blue. So this formation is called as the built up edge one. This formation of the blue is cyclical in the form and grows and then because unstable and break off one. So it is the one of the continuous chip breakup. So next one is we can see prevention of built-up edge chip formation one. So some of the prevention we can see on the built-up edge one. The formation of the built-up edge is also referred as a chip welding one. So since chip welding has a considerable and advised effect on tool life one, power consumption one, and surface finishing one, every attempt must be made to prevent it occurring one. So see here, it is the some of the preventions we can see on the built-up edge chip formation one. The formation of the built edge is also referred as the chip welding one. That is first point one. Since chip welding as a considerable and chip welding is nothing but one of the considerable one and advised effect on the tool life. It is one of the effect we can see on the tool life, power consumption and surface finishing. Every attempt must be made to prevent it occurring one. So every attempt it will be made to prevent its occurring one. So it is the one of the preventions on the built up edge formation one. The major one is this one. So the chip welding has considerable and advised effect on the tool life, power consumption, surface finishing, good surface finishing. These are the major one preventions. So next one is we can see prevention of built-up edge chip formation one. We can see this is largely achieved by reserving the conditions that causes the chip welding in the first place one. Prevention is mainly done by reduction of friction. So first of all, we are reducing the friction one. Next one, reducing the pressure. Pressure will be reducing here. Preventing the metal to the metal contact one. Preventing the metal to metal contact is we are preventing here, reducing the temperature. So this is one of the prevention is mainly done on the built up edge chip formation one. So we can prevent these conditions. Optimally, we can get good surface finishing one, good accuracy, good shapes and size one. Exact shape and size, good surface finishing we can get on the this chip one. So it is the third one, Amma. So it is our today topic one. So the first one is see here once again. First one is what is the chip. Next one is what is a chip. So and types of chip and chip formation one. Theory of chip formation one. So it is the first one. What is the chip? So the cutting tool remove material. The cutting tool remove material from the workpiece in the form of the chip one. This one we can call as the chip. So next one is theory of chip formation one. We can see another point here. So another point is nothing but we can see shear plane here. So shear plane also again we have the two ones. The first one is primary shear. Next one is secondary shear. Also we can see on the shear plane one. So next one is we can see. So next one is theory of chip formation one. Theory of chip formation one is corresponding thickness. Before chip formation one, we can get on T naught. The corresponding to the before the chip formation one, we are getting T naught. The chip is formed, that is nothing but Tc. So we have the one equation one. T naught is always greater than the Tc. Why? Because so the thickness is increasing. T naught equal Tc. T naught is before chip formation one. Tc is nothing but chip is formed. So that's why T naught is always greater than the Tc. Like this. This is the chip is formed here before chip formation one. This one T naught. So that's why T naught is always greater than the Tc. It is a tool. It is a work one. This is chip thickness one. This is chip thickness one. Chip thickness ratio we can see here. The theory of chip formation one. The ratio of T naught and T naught and Tc is called as the chip thickness one ratio. So therefore R equal simply chip ratio R equal T naught by Tc here. Since the chip thickness after cutting is always greater than the corresponding thickness before the cutting, the chipness ratio will be always less than 1. The chip ratio will always be less than 1. So the ratio of the T naught and Tc is called as the chip thickness ratio. Simply mathematically, how can we write the chip thickness means R equal T naught by Tc. Since the chip thickness after cutting is always greater than the corresponding thickness before the cutting, so that's why the chip ratio will be always less than 1. So this one we can call as the chip thickness ratio. Next one is we can call as the types of chip. So chips, what is the chip and types of chips we are learning here. So chips are generally classified into 3 types one. So how the chip will be formed? The chip that are formed during the metal cutting operation, such as some of the classifications we can see on this chip one. The first one is discontinuous segmental chips. Second one is continuous chips. Third one is continuous chip with the buildage one. So these are the 3 types of chips. First one is discontinuous chips. This one is a block diagram one. It is a tool. It is a workpiece. So we can get the chip is a discontinuous chip. This one. So next one is we can get a continuous chip. Some of the points one. So definitions. So next one is you can see continuous chip one. So it is a tool. It is a workpiece. So continuously it is removing the chip one. So that's why you can call as continuous chip one. So in this continuous chip one, we can see high cutting speed. We can see good surface finishing. We can see on the continuous chip one. So some of the points you can see on the chip formation one. So it is a deeply detail of the block diagram of the chip form continuous chip one. Clearly block diagram of continuous chip one. It is a tool. It is a workpiece. And so the tool is removing like this 1 2 3 4 5 6 7 8 9 10. It is a continuous chip formation one. So next one is a continuous chip formation. Some of the conditions, ideal conditions. This one. It is some of the points of the continuous chip one. So continuous chip onwards, we can see another one. It is chip ruler one. It is one of the chip one. Next one is groove type chip breaker. This one. So it is the different types of chip breakers. The first one is chip rule. Next one is groove type chip breaker. Next one is clamped objection type chip breaker one. So this next one is continuous chip with built up edge one. So it is one. So the third, chip formation. Some of the preventions we can see on the this chip formation. So it is our today class one. So chip formation one, theory of chip formation one, first one. So next one is types of chip one. So next one is chip breakers one. Next one is chip ratio, chip thickness ratio. So these are the 4 points we are discussing today class one. Thank you.